I am sharing my screen. I think this is our 11th lecture and we will read about mutual exclusion and semaphore. What is mutual exclusion? In computer science, mutual exclusion is a property of concurrency control which is instituted for the purpose of preventing race condition. What is race condition? When more than one process is asking for same resource, then it is called race condition. Suppose there are 2 resources and 10 processes. All the 10 processes want to use the same resource at the same time. That is called race condition. Mutual exclusion is the requirement that one thread of execution never enters its critical section at the same time that another concurrent thread of execution enters its own critical section. Critical section, what I have explained is that critical sections are some important steps which are used for calculation. Now suppose there are 2 transactions happening on the same bank database. One of them is adding rupees 100 and another process is deducting rupees 100. What will happen? It will, the system state will become inconsistent because at the same time the addition and subtraction is being done from the bank account. So it will give incorrect result. So that is why it is mentioned that it is the requirement that one thread of execution never enters its critical section at the same time the another concurrent thread of execution enters. It refers to an interval of time during which a thread of execution accesses a shared resource such as shared memory. So this is the definition of mutual exclusion. Mutual exclusion occurs when there are more than one process and they want to use the same resource at the same time. This is the concept of mutual exclusion. Mutual exclusion, it can be referred to as mutex. This is a concept. Syntactically, when they are executed, they are termed as mutex. It is a program object that prevents simultaneous access to a shared resource. That means shared resource, whenever there is sharing of resource and the process is performing a write operation, then there should be a lock on that transaction and that lock can be given with the help of mutex command. Mutex command is a program object which gives the command for mutual exclusion. That is the concept of mutual exclusion. Now this concept is used in concurrent programming. Concurrent programming I have already explained. it means concurrent programming means when more than one processes are executing at the same time. Let me draw one or two diagram, then I think it will be easier for you all to understand. I'm sharing the whiteboard. My whiteboard is visible to you all. If there is, you are not
Yes,
able,
ma'am.
okay, good. Now I will write critical section. Then suppose this is, there are two arrows at the starting and end of the critical section. Now what we will do, acquire the lock. The lock is acquired at the beginning of the critical section. And here release the lock. At the end, the lock is released. So this is the diagrammatic representation. Here we will write lock is locked. Here we will write lock is unlocked. So this is one of the depiction of critical section, where we have executed critical section. I am drawing another diagram. I think all of you have written, those who want to write, they have written in the notebook. So I will write another diagram which will show the concept of mutex. So let us clear this. I'm again drawing. Right. Thread. Suppose these are thread. We have learned what is thread. Now draw a rectangle. And there's a two-way communication. What I will write here, text, then I will write shared resource. Okay. So this is the mutual exclusion condition. What I will write here, I will write wait, and then again I will again write release. There is a two-way process. That let me again draw this, then I will explain. Here also there are two options, wait and then this is the complete diagram. See, you can find mutex. Mutex is a variable or is a portion which ensures mutual exclusion, and with mutex threads are attached. Whenever shared resource is accessed by more than one process, then mutex lock is used. The process which has entered the critical region, it will execute, and the other threads, other processes will wait for the CPU time. Once the mutex or mutual exclusion lock is released, look here it is written release. Once it is released, then mutex variable is free and can be used by others. That means at one time only one process can enter in critical section. Now I am closing this. Let me share again. We go to the next slide. Problem description. The problem with mutual exclusion address is a problem of resource sharing. How can a software system control multiple process access to a shared resource when each process needs exclusive control of that resource while doing its work? It means each and every process wants exclusive control of the resource while doing work. The mutual exclusion solution to this module, the shared resource available only while the process is in specific code segment called critical section. What is critical section? When the process enters critical section, then mutual exclusion is the only solution which is being given to avoid the problems. It controls access to the shared resource by controlling each mutual exclusion of that part of its program where the resource would be used. Now critical section. Critical section here, critical section is explained diagrammatically. All the processes are written and they are being explained part by part. Critical section is the part of a program which tries to access shared resources. Critical section comes into picture when there are several access, when there are several processes or shared resources are there and each and every process wants to use it. Critical section problem is used to design a set of protocols which can ensure that the race condition among the processors will never rise. After it refers to the problem of how to ensure that at most one process is executing its critical section. Again, critical section in different threads are not necessarily the same code data. Let us draw one diagram of critical section So I am going to my whiteboard. Let us draw something. Now we will write do. Wait, just wait for 1 minute. I have
Hello.
Sorry,
Hello.
sorry, I was unmuted. I was muted, I think. So
Yes, ma'am.
I wanted to ask: is there any confusion up to this point, or you have understood what is deadlock?
Ma'am, I didn't hear what you explained just before last two
Okay,
slides.
no, I am
So,
explaining again. I didn't notice that I was
okay.
mute. So I
Ma'am, that's what I was noticing. You were just changing the slides. So I thought there is a problem in mine. So I checked my
no,
phone and again
I missed.
then I,
Wait, let me.
okay.
These are the different problem solutions ideas. First was any solution to the critical section must satisfy few requirements. Second, mutual exclusion is executing in its critical section. Then it should be ensured that only one process can execute in critical section. Rest of the processes should wait. And third point is that it must be free of deadlocks. What is deadlock? Can anyone explain? What is deadlock?
Ma'am, it may be the something like dead end that and after any process enters in the critical zone, it will lock at
Yes,
that point that no other process will enter.
yes. Deadlock means where cycle is occurring and the other processes also get stuck due to dependency on one process. So let us go to next slide. This is program execution cycle 1. Each process program can be partitioned into 4 sections. Whenever we are executing a process, what is process? Whenever you write a program and execute it, that is called a process. Every process program can be partitioned into 4 sections. First is non-critical. Non-critical means the operations, the transactions which are being done outside critical section. Process is not using or requesting the shared resource. Trying, the process attempts to enter the critical section, but maybe there are two chances: either it is successful or not successful. Then critical section, process is once the other processes left critical section, then the another process which is waiting for critical section can enter. That process is allowed to access the shared resources. Exit, the process leaves the critical section and makes the shared resource available to other process. So basically these are 4 steps of program execution cycle. This is shown diagrammatically also. The diagram is clear to you all or not? I don't know whether the diagram is properly visible to you all. What is program execution cycle? If a process wishes to enter the critical section, it must first acquire or it must first execute the trying section. There are 4 sections that is shown in the diagram. One is trying section and wait until it acquires access to critical section. Unless and until the process is going to critical section, it is executing in trying section. After the process has executed its critical section and is finished with the shared resource, it needs to execute the critical section to release them for other processes. The processes then returns to non-critical section. One of the disadvantage of this principle is at times it may cause a deadlock scenario. And to overcome, we need to work out for deadlock freedom. What is deadlock? When there is a cycle, you are drawing a graph, you are drawing a diagram, and you find out that there is a cycle that is happening. At that time you will understand that there is a deadlock. Deadlock freedom. These are different deadlock freedom strategies. I think before looking into the strategy, I am again sharing my whiteboard with you, where we can draw the diagram of the deadlock. Resource 1, resource 1, then if we consider only two processes, process 2 and process 1. There are two processes, process 2 and process 1. Again, we can draw resource 2. There are two resources and two processes. This is a simplified version just to make you give the knowledge. Look at the diagram carefully. A cycle is present. If you look at the direction of the arrow, you can see that the cycle is present. And whenever a cycle is present, then we can say that the states or the processes has entered deadlock state. Okay, this is the diagrammatic representation of, again, if we look into this, I can say that assigned to that assigned to, you can write waiting for, assigned to and waiting for. That means for completion of process P1, resource 1 is assigned to process P1, but process P1 is waiting for resource R2. R2 is assigned to R2, resource 2 is assigned to P2. And process 2 is waiting for. So this is the complete diagram. We can say that here we can label the diagram as deadlock. In deadlock in operating system. So what is deadlock in an operating system? See, process P1 has acquired resource 1. It is waiting for resource R2 for completion. And at the same time, process P2 has acquired resource 2 and it is waiting for resource R1. So there is a complete cycle that needs to be broken. If while drawing, if there is a cycle, then we can say that a deadlock is there. Now if we go over, these are some techniques of deadlock freedom. How to enforce mutual exclusion? Multiple ways have been built in order to ensure mutual exclusion. Some using both the hardware and software solution. Some common hardware solution comprises of a uniprocessor system. The simplest solution to achieve mutual exclusion is to disable interrupts during a process critical section. Busy waiting is affecting for most uniprocessor and multiprocessor systems. Some common software solution using busy wait algorithm works. These are different algorithms: Decker's algorithm, Peterson's algorithm, Lamport's bakery algorithm. These algorithms, when executed, they help in enforcing mutual exclusion. Mutual exclusion devices. This is the diagrammatic representation. So we say that to ensure mutual exclusion, software solution can be used to build the synchronization primitives as locks, reader-writer locks, recursive locks, semaphores, monitors, etc. Now, there is semaphore. Semaphore, what is semaphore? It is a variable. Remember that semaphore is a variable or abstract data type. Why is this abstract data type? Because it is not assigned a particular data type. It is not like that semaphore is a integer data type, float data type. It is not like that. It is abstract data type and is used to connect access to a common resource by multiple processes in a concurrent system, such as multitasking operating system. Now, if we want to give an example, if at most 4 threads to be able to enter a section, we could protect it with a semaphore and initialize that. But what we initialize, that is initializes the semaphore to 4. I am continuously speaking. None of you is stopping myself and no one is asking. What I will do in the next class, I will take a small test. Remember that. Suraj, you convey this message to others.
Okay, ma'am.
Okay. Now semaphore, how it works, it is shown diagram. I have already explained. There are for S1, S2, S3, S4. Now we look into another one. These are semaphore types. What are different types of semaphore? Binary, counting, mutex. Binary semaphore, they can take the value of 0 and 1. They have no ownership and can be released by any task or ISR. Counting semaphore is a non-negative count. Counting semaphore are used to coordinate access to resources. Counting semaphores don't have a defined order of unblocking. Unblocking exists if multiple threads are waiting for semaphore. Now let us go to next slide. Mutex. Again, the mutex is explained. Mutex lock is essentially a
Ma'am, sorry to interrupt. Ma'am, can you please explain me one more time what is actually semaphore is? I'm a bit confused after reading the
Listen,
type.
Suraj, what you want to say? There is some noise coming from your side. What you want to say? I
Yes,
should explain which part.
semaphore. What is semaphore?
A
I
semaphore
got
it is.
confused after the
Okay.
reading the types. I got a bit confused.
You want me to explain semaphore? Semaphore, these are variables. And there are three types of semaphores: binary, counting, and mutex semaphore. It means mutex is a variable. It is nothing but a semaphore. I will share this slide with you. All of you go through the definition of semaphore and its type. If there is a confusion, come back to my class and ask question tomorrow or maybe day after tomorrow. Tomorrow is a holiday. The notice is circulated to us.